this is going to be page 7 of your pamphlet. So the topic is going to be fission. We've already shown what fission is on page something or another. Page 5, and we've talked about how much power fission produces on page 6. So on page 7, because you need to know about nuclear power used for electricity purposes and the pros and cons of using fission or nuclear power for electricity, you kind of need to know what can and can't happen at a nuclear power plant. And one of the things that cannot happen at a nuclear power plant is an atomic explosion. Atomic explosions cannot occur at a power plant. And the reason they cannot occur, or for you to understand why they cannot occur, you have to know how to make an atomic bomb. So you're going to write a little bit of an explanation, and then you're going to draw some things. So your explanation has to be something along the lines, or something that includes how to create an atomic bomb. So you might want to give a little title here, how to create an atomic bomb. Now this is an atomic bomb or an A-bomb or a fission bomb. There are different types of nuclear explosions, and we're talking about a fission explosion or an atomic explosion. These are called atomic bombs, fission bombs, A-bombs. So if you want to have an atomic explosion, you have to get all of the uranium atoms or plutonium atoms to split and release their energy all at once or simultaneously. Simultaneously means all at once. That's what an explosion is. So you have to get them to be split as close to all at once as possible. So somewhere in here, you need to give me a brief definition of how to create an atomic explosion. You must get all of the uranium or plutonium atoms to split all at once as much as possible. And then I want you to draw a graph. And this graph is going to show, we love graphs in science, we love graphs in general in life. This graph is going to show what we're talking about. If you look at time, and this would be in probably millionths of a second. I think I spelled that right. You might want to check me on that. And if you looked over here on the y-axis, the number of atoms that are split, you want your graph to look like this. You want it to go almost vertical. It's never going to actually quite be vertical, completely vertical, but it's going to be really close. It's always going to infinitely trying to get to vertical. So that's really what you want. This means that your atoms are essentially splitting all at once, okay? And then below that, you're going to show an atomic explosion, which is made possible by what we call implosion of atoms. So before, you might have this group of atoms, and we're just going to draw some circles. And the way that we get this implosion to occur is we encase these things in TNT. Now this took a lot of money and research to understand how to get this to occur precisely so that we would have an atomic explosion. But this blue stuff is the TNT. So somehow you need to label that encasement of blue the TNT. And of course, this is a uranium-238 atom. And then after implosion, after we detonate the TNT, these things are all going to be really close to each other. So this is before implosion. This is after implosion. And it's physically simply that the atoms are really, really close together. And they're so close together because of the implosion of the TNT that when we start firing neutrons, it all splits simultaneously and releases all of its energy simultaneously. So that's page 7. Give me a title, fission. Give me a subtitle, how to create an atomic explosion. Atoms of uranium-238 must be made to split simultaneously or at the same time as much as possible. And then draw a graph which represents that, and then the way that we do that is we implode them using TNT. You can actually go on the internet and look up how to make an atomic bomb. The issue is getting the uranium. That's not easy to get because in most countries, it's owned by the government. The government declares that it owns all uranium or plutonium. So, or you could get a bunch of glow-in-the-dark watches, like 1 million of them, and scrape off all of the radioactive material there, if you want. Page 8, fission, and that is going to be a nuclear power plant. Sorry for the writing, I'm going really fast. So, nuclear power plant. So you're going to write something along the lines of, because uranium-238 must implode to create an atomic explosion, you cannot have an atomic explosion at a nuclear power plant. However, you can have a runaway chain reaction, which could cause a meltdown or a chemical explosion. So you want to put all that into your writing there, okay? And then we're going to quickly redraw kind of maybe a smaller scale of fission. This just kind of reiterates what fission is. And you split these big atoms, and this, of course, is radioactive waste, RW, okay? This is a neutron. And you get a lot of energy, and then you get other neutrons. These are other neutrons that are produced in every split. You get 2 to 3. And these will repeat the process. So you kind of want to put all that down. So the neutrons, and then you're going to write a bunch of stuff. The neutrons keep the reaction going and produce a chain reaction. Again, I'm just kind of going fast. You can go back and re-listen to it. They keep the reaction going and produce a chain reaction, okay? If the chain reaction is uncontrolled, it will produce too much energy, which can lead to either a chemical explosion and or a meltdown where radioactive material is released to the environment. However, there can be no atomic explosion because you cannot have implosion. All right, so that's page 8. Now page 9, we're going to talk about fusion. So fusion, and you're going to define fusion. Fusion is the process that powers the stars. And fusion occurs when you take 2 atoms and you fuse or combine them into 1 atom. You fuse or combine them into 1 atom. Fusion in the stars occurs when hydrogen is combined into 1 atom, and the product is usually helium. The great thing about fusion, and then you're going to write all of this, the great thing about fusion, or one of the advantages of fusion, is that it produces an enormous amount of energy, almost millions of times more energy than fission. So fusion dwarfs fission the same way that fission dwarfs fossil fuels. However, There are pros and cons to all energy sources. Fusion produces too much energy, and you're putting all this into words somehow. Fusion produces too much energy, so much that we cannot control it. We literally cannot control the amount of energy that is produced. And fusion requires an enormous amount of energy to get it started. It requires an enormous amount of energy to get it started, and in fact, the only way that we can actually start fusion is by exploding a fission bomb. So those are the cons. The advantages of using fusion, if we could ever figure it out, are that it produces no radioactive waste. It produces an enormous amount of energy, much more than fission, and we have an unlimited supply of fuel because we can get all the hydrogen we need from water, and we have a lot of seawater, salt water. So those are the pros and cons of fusion. Currently, this is page 10, again titled Fusion. So currently, you're going to tell me that currently we can only use fusion for nuclear weapons. Now these weapons are also called H-bombs or hydrogen bombs or thermonuclear weapons, which is different from a fission bomb or an A-bomb or an atomic bomb. So a hydrogen bomb essentially is a fission bomb that must be detonated to make the hydrogen fuse. And so with fusion bombs, you actually do get some radioactive waste. But the only way that we can start this process, and you don't have to put anything, you don't have to write anything below that, the only way that we can start this process is to actually detonate a fission bomb. So all of our hydrogen missiles have fission bombs in them. And we're going to stop there.